Welcome learner, Department of Collegiate and Technical Education has provided us online teaching and learning platform through LMS. Under this program, we take up the course PCB Design and Fabrication Lab. Subject code is 15EC56P for 5th semester Diploma in Electronics and Communication Engineering students. Under this Unit 1, Introduction to PCB, Session 3 now.
Electronic design automation tools and comparison. The following are the electronic design automation tools: KiCad, Express PCB, Electronic Workbench, OrCAD, Circuit Maker, Eagle, Multisim, and DipTrace. These are all the EDA tools available for the students to design the PCB. Features of KiCad: 3D viewer that enables PCB board designers to inspect the layouts in an interactive canvas. 3D viewer is the special feature provided by the KiCad software. In that 3D view, a designer can see how the board will look like once the board is manufactured, once the PCB is manufactured. KiCad is extremely fast when compared to many circuit board design software. KiCad software is fast because the KiCad software is designed by using the programming language C++. Features of KiCad: the open source model of KiCad allows developers to inspect the source and modify the application if required. The source file model KiCad allows the developers to inspect the source file and modify the when it is required in the future. Chip manufacturer can select from a wide range of external tools and libraries for this EDA application. For KiCad EDA application, the chip manufacturer provides sufficient information about the packages such as pin dimensions. The actual mechanical dimension of the components are provided by the chip manufacturers of various companies. Feature of Eagle: the schematic editor supports modular design blocks, spice simulator, electronic rule checking. These are all the features available in the Eagle. Spice simulator built with the PCB design software, and electronic rule checking is the one of the feature of the available in the Eagle software. Its PCB layout editor allows for simple alignment tools, push and show routing, obstacle avoid routing, and high-speed design. In push and show routing, a router can push the set of tracks or push the bunch of tracks together in a PCB. Obstacle avoid routing allows the designer to the easiest path or smooth path within the PCB wherever the pads crowd is less. High-speed design: the Eagle software has provided one more feature, that is high-speed design. In high-speed design, layer stack-up has been prepared, and also the tracks are designed for impedance of 50 ohm or differential pair. Tracks can be designed for 100 ohm impedance. Free version of this circuit board design software for students and academicians. For students, a free version of Eagle software is available. Features of EDA tool: these are all the features of most of the EDA tools available in the market for the PCB design. Flip horizontal: the component can be flipped horizontal and vertical. Features are provided in a sophisticated PCB design tool. Expanded hole sizes: once the PCB starts routing, the size of the hole can be extended or the size of the hole can be increased. Design rule check is the feature provided by the EDA tool. Silk screen on bottom layer: some of the PCB design demo version will not allow us to design the silk screen for bottom layer, but most of the EDA tools nowadays provide silk screen on bottom layer also. Traces on inner layers: expanded undo function There is a limit for undo function, but some of the EDA tool provide the feature more number of undo functions. Shift key to constrain horizontal or vertical movement. The horizontal and vertical movement of the component can be done by using shift key plus H, shift key and V. Auto number reference designator. The components having its own namings, but the software will provide the feature of numbering by the software. We have to generate auto reference designator command, then it will give its own naming to the components. Features of the EDA tool: auto zoom and center netlist error, zoom in and zoom out features are available, and centering the error present in the PCB and highlighting the error present in the PCB and netlist are shown in some of the softwares. Ability to connect wire to more than one inner layer for multiple ground planes. Wires can be stitched into ground planes. That feature can be available in the EDA tool. Highlight wires and pins in layout that are connected. The pins and wires can be differentiated by giving the different colors to pins and wires. Enhanced solder masking editing feature is available, is one of the important feature in the EDA tool. Enhance part editing and grouping. Grouping the certain similar kind of components somewhere and placing together inside the PCB is possible. If the similar kind of circuits are present in the same PCB, then grouping of the component and placing of the component is very easier. The board can be finished soon. Bill of material. Bill of material provides a number of components present in the PCB. It is easier for the designer to estimate the cost of the PCB. Enhanced printing functionality. A common decision to make for hobbyists or inventors is KiCad versus Eagle. ECAD and KiCad. KiCad and Eagle, both are the softwares are available for the hobbyists and inventors. And in future, we can compare both Eagle and KiCad softwares. Both of them are decent programs for designing your own printed circuit boards. KiCad has its own set of some attractive features. Eagle software is also having its own attractive features. We cannot say which software is best and which software is worst, but both are very popular. KiCad versus Eagle. Price wise, KiCad is free and open source software. Eagle has both a free version as well as a paid version. User comparison, user interface comparison. KiCad has a set of keyboard shortcuts for doing standard tasks like rotating a component or drawing a wire. W can be used to draw the wire or take the wire, and R can be used to rotate the component clockwise. A component must have a symbol that you can use when designing the schematic. For designing the schematic diagram, we required the symbol. For designing the PCB, we required footprint. For drawing the schematic diagram, symbols are available in the symbol library. Organizing components, KiCad versus Eagle. Under this, organizing components, and it needs to have a footprint with pads and holes that will be created on the PCB for soldering the components. The footprint consists of pads and holes that is used for soldering the components. In this KiCad, we have to design the footprint for the component. If the footprint is already available in the library, then we need not to create the footprint for the component. Both Eagle and KiCad come with libraries that have the most popular components included. Most of the components footprints are available in the KiCad's library as well as Eagle library. Standard components are available in the KiCad library. KiCad versus Eagle. The design process in Eagle In Eagle, here is how you design the PCB from scratch. There are easier steps provided by the Eagle software. These steps are: create a schematic is the first stage, choosing the component and which footprint is used for the component, and under this we can choose the footprint which is suitable for that components. Place the components and connects the circuit like you want. The circuit diagram is provided by the design engineer. By looking at that, by seeing that, by referring that, we have to design the circuit diagram or capture the circuit in the PCB design software. KiCad versus Eagle. Then process steps are continued here. Click on the generate board button. Generate board button is available. That you have to click. By clicking that we can design the board dimension, draw the board dimension. By looking at the dimension given by the engineer, we can draw the diagram or take the dimension based on the dimension provided by the engineer. Now you have all the footprints for your board in a pile, and you can start placing and connecting them. All the components are going to fill in the pile. From there we have to take the component one by one and start placing. If you have to change something in the schematic, you do that, and the changes will also happen on your board. If you change anything in the schematic, that will be reflected on your PCB and layout stage. It's pretty straightforward. The Eagle software is pretty straightforward compared to the KiCad. KiCad versus Eagle. The design process in KiCad. First, instead of choosing which footprint you want to use, when you choose the component, you choose the footprint for all the components at the end. Here in this KiCad software, at component mapping, we have to choose the footprint for the particular symbol present in the schematic diagram. Second, the components do not get a proper name until you run the annotate schematics command. Once we run the annotate schematic run command, then only component will take the proper name. The design process in KiCad. Third, you have to run a create netlist command, then load this netlist into the board designer for creating the board. We have to import this create netlist command. Once we have generated the create netlist command, then only the components are going to the PCB layout editor. These steps make KiCad seem more complicated when starting out, but after you have done them a few times, it's not really something you think about. Some of the designers will think that the Eagle software is very easier. Once a designer has chosen the KiCad for his design, then he feel that much more comfortable in KiCad than the Eagle software, because Eagle software will take the component from its library from its by its own decision. Therefore, lot of errors will appear in the Eagle software, but erasing of the error is less in case of KiCad software, because we are assigning the footprint. Sometimes in Eagle software, that will take the footprint. If the footprint is not available for 20-pin IC, then it will take the footprint of some other IC. It may consist of more than 20 pins. That will create unconnected pins problem. But Eagle definitely gets more beginner friendly points here. A beginner can learn easier by Eagle software. KiCad versus Eagle. KiCad's secret weapon is 3D view. One major plus point of the design process in KiCad is its built-in feature of 3D viewer. This is the attractive feature provided by the KiCad software. When you have designed your board, you can press Alt 3 and your design pops up as a 3D model. The 3D model shows how the PCB will looks like once it is manufactured.
The engineer want to know how my board will look like. In other software, he can view that only after the board is manufactured. But in Eagle, in KiCad, it is not like that. He can see his board, manufactured board, 3D model while designing the board itself. Eagle does not have a 3D viewer. KiCad versus Eagle. Conclusion. Should you choose KiCad or Eagle? The answer is below. Eagle and KiCad are pretty similar in many ways. The ultimate goal of both the software are similar, but few steps are different from the another. Component mapping and netlist generation. You can design simple circuits on both. Both the circuits can be easier for simple circuit design, and you can also design the advanced circuits on both. It also, if you have knowledge, if you have tricky enough, you can design advanced circuits also. KiCad versus Eagle, mainly because of the default keyboard shortcuts and the 3D viewer in the KiCad, this might change in future again. The default keys and 3D views present in the KiCad software that may be changed in the future. That is left to the software designers of the KiCad software. For a beginner, KiCad is the best tool. DipTrace versus KiCad. Price wise, KiCad is free version. DipTrace basic version available for $75. You can design 2 layers board with maximum of 300 pin. You can accommodate maximum 300 pins. DipTrace full version $995. It will available with full feature. Evaluation version of DipTrace you can download freely, but some of the features are masked. Some of the features are not given to the designers in the evaluation version. 3D views of the component is possible in both the softwares. High speed design is not possible in KiCad. High speed design is possible in DipTrace full version. Length matching is not possible in KiCad. Length matching is possible in DipTrace. DipTrace versus KiCad. Impedance matched traces cannot be designed in KiCad. Impedance matched traces can be designed by using the KiCad. Here impedance matched traces means the transmission lines, strip line, micro strip line and asymmetric strip lines, transmission lines can be designed in the DipTrace software. HDI is not possible in KiCad. High density interconnect. HDI stands for high density interconnect, is possible in DipTrace full version. Now, what is DDR signal routing in EDA tool? DDR signals can be routed by using Eagle softwares. What is DDR? Before that we are going to know. DDR stands for double data rate, transfer of data on both the rising and falling edges of the clock signal. For each clock signal, 2 times data are transferred. One is at the falling edge, another one is rising edge. DDR signals are routing in EDA tool. Here in this diagram, how the DDR signals are routed as shown here. Here length has been matched. The data signals from D0 to D7 or D0 to D15 are routed through this. The address lines also routed the pattern of like this. While routing the tracks, you have to take all the tracks in, try to take in same layer because of the impedance matching. If you tries to push it to another layer or some other layer which has to designed for the same impedance, and impedance should not be mismatched while routing this kind of tracks in DDR. But one of the major thing you have to follow is route the address signal, data signal, control signal and clock signal is the procedure for routing the DDR signals. HDI features in EDA tool. The most common types of HDI boards include through vias from surface to surface, combination through vias and buried vias and blind vias, multiple HDI layers containing through vias. A passive mounting substrate without any electrical connections. We can connect the component without any electrical connections by using vias and pads and surface mount pads. Coreless construction through the use of inner pairs. Alternate coreless constructions through the use of layer pairs. Why the HDI explained here means the HDI is one of the feature is provided by the EDA tool at the present marketing. The advanced EDA tools provide HDI features, but the EDA tool cost is more. HDA features in EDA tool. Micro vias are the smallest via holes with the size equal to or less than 150 microns. The via diameter here is 150 microns. It is 0.15 mm diameter. Very small. Not even 1 mm. 0.15 mm diameter. Sometimes it may be 0.1 mm. That is depending upon the laminate thickness present here. These vias usually only connect on one layer of the board to its adjacent layer and have a very small diameter. Here also via present. This buried via is called micro via when the diameter is 0.1 mm or 0.15 mm or 150 micron. Staggered vias are used when a blind via is required but exceeds the aspect ratio of 1:1 and cannot be formed through the sequential lamination due to another blind or buried via beginning on the same layer as the blind via's termination layer. In order to achieve the aspect ratio 1:1, the vias are dropped from one layer to another layer. This is not possible to drop from this layer to this layer because we want to get to the aspect ratio of 1:1. Eagle can create the via can be dropped from 1 layer to 2 layer, 8th layer to 9th layer and 15th layer to 16th layer. It is not possible to drop the via from 2nd layer to 8th layer, 9th layer to 15th layer. One of the most important feature available in the EDA tool are template routing is one of the important feature in some of the EDA tools in which mainly components are grouped. Similar components are grouped together and it can place at a time. We can copy the pattern of placement to another set of components and another set of components and 4-5 groups where can be placed at a time. Routing pattern of similar groups are same, therefore we can copy the routing pattern and paste it. Routing become easier. So routing process completed faster by using this feature available in the software. Now questions. EDA stands for Electronic Design Automation, Electronic Design Authority, Electronic Devices Automation, Electronic Devices Authority. Now the answer is A. Electronic Design Automation. Second question. A learner can effectively use the following software for the PCB. PAD software, KiCad software, Allegro, Board Designer. Obviously the answer is KiCad, B. Question 3. Following is the PCB design software. PAD software, KiCad, Allegro, all the above. All three softwares are PCB design software, therefore answer is all the above, D. Fourth question. Following is the cheaper PCB design software. PAD software, KiCad, Allegro, Board Designer. KiCad is a free version, it is open source software, therefore answer is B. These are all the references and apart from that, thank you for watching.